Hello? No way. I was muted that whole time. Well, the first 12 minutes of the stream is silent, or 13 minutes. Thanks for telling me. For some reason, I don't even want to go into it. I'm going to get triggered. But let's just say there was a particular operating system that did a particular update last night. And I guess for some reason that means my microphone doesn't work anymore. Or rather why would that change OBS settings, you know? That's okay, thanks for letting me know. Damn, I said a bunch of stuff, but that's fine. I just said, actually, I'm going to do some reading. So I'm going to read through this, and the reason is because looking at these samples and changing the shaders, because like, I don't know why do we do this? Like, what is this? Is this converting to a specific type of coordinates? What's the reason for it? I get this part, I suppose. Once we calculate the UVs, we can get the pixel at the particular point in the depth buffer. But then current depth is based on this projected Z coordinate. How did that happen? Based on this, I guess. So I just want to understand more of this because I'm not able to get it working properly. And I can't really debug it without knowing what I'm doing. So yeah, let me start again. Shadows are a result of the absence of light due to occlusion. When a light source's light rays do not hit an object because it gets occluded by some other object, the object is in shadow. Shadows add a great deal of realism to a lit scene and make it easier for a viewer to observe spatial relationships between objects. They give a greater sense of depth to our scene and objects. For example, take a look at the following image of a scene with and without shadows. That's true. These look like floating boxes. At least they do to my eyes. Like this one looks like it's tumbling down. It's really hard to tell where they are. You can see that with shadows it becomes much more obvious how the objects relate to each other. For instance, the fact that one of the cubes is floating above the others is only really noticeable when we have shadows. Oh, it is actually a floating box. But it also could have just been far back, yeah. Shadows are a bit tricky to implement though, specifically because in current real-time graphics, a perfect shadow algorithm hasn't been developed yet. There are several good shadow approximation techniques, but they all have their little quirks. Our technique, one technique, is used by most video games that gives decent results and is relatively easy to implement. Yeah, I'm going to take umbrage with this statement. But maybe that's just because I skipped too much. So I skipped ahead too much and then gave myself a big headache. So it's called shadow mapping. Shadow mapping is not too difficult to understand, it doesn't cost too much in performance, and quite easily extends into more advanced algorithms like omnidirectional shadow maps and cascaded shadow maps. The idea behind it is quite simple. We render the scene from the light's point of view, and everything we see from the light's perspective is lit, and everything we can't see must be in shadow. Imagine a floor section with a large box between itself and a light source. Since the light source will see this box, and not the floor section when looking in its direction, the specific floor section should be in shadow. Yeah, understood. Here all the blue lines represent fragments that the light source can see. The occluded fragments are shown as black lines, yeah. These are rendered as being shadowed. If we were to draw a line or ray from the light source to a fragment on the rightmost box, we can see that the ray first hits the floating container before it hits the rightmost container. Yep. As a result, the floating container's fragment is lit and the rightmost container's fragment is not lit and thus in shadow. We want to get the point on the ray where it first hit an object and compare this closest point to other points on this ray. We then do a basic test to see if a test point's ray position is further down the ray than the closest point, and if so, the test point must be in shadow. To see if a test point's ray position is further down the ray than the closest point. Yeah, okay. Iterating through possibly thousands of light rays from such a light source is an extremely inefficient approach and doesn't lend itself too well for real-time rendering. We can do something similar, but without casting light rays. Instead, we use something we're quite familiar with, the depth buffer. You may remember from the depth testing chapter that a value in the depth buffer corresponds to the depth of a fragment clamped to 0 and 1 from the camera's point of view. What if we were to render the scene from the light's perspective and store the resulting depth values in a texture? Well, that would look something like up the top there, like right up here. Okay. This way, we can sample the closest depth values as seen from the light's perspective. After all, the depth values show the first fragment visible from the light's perspective. We store all these depth values in a texture that we call a depth map or shadow map. Oh, interesting. I think I know why my thing is broken. Now that I'm looking at this, maybe? Depth map, shadow map? Maybe not. Okay, let's keep going. So you can see we've got two images here. Z distance stored in texture. I just said Z for some reason. Yep, that's great. There's the projected shadow, yep. The left image shows a directional light source. All light rays are parallel, casting a shadow on the surface below the cube. Using the depth value stored in the depth map, we find the closest point and use that to determine whether fragments are in shadow. We create the depth map by rendering the scene from the light's perspective, using a view and projection matrix specific to that light source. This projection and view matrix together form a transformation that transforms any 3D position to the light's visible coordinate space. Yeah, okay. A directional light doesn't have a position as it's modeled to be infinitely far away. However, for the sake of shadow mapping, we need to render the scene from a light's perspective and thus render the scene from a position somewhere along the lines of the light's direction. That's right. So, in the right image, we see that the same directional light and the viewer. Okay. We render a fragment at the point P, for which we have to determine whether it is in shadow. Okay. To do this, we first transform point P. Is there some special name for this thing above it? Probably. Point P to the light's coordinate space using T, which is our transform matrix, right? Since point P is now seen from the light's perspective, its Z coordinate corresponds to its depth, which in this example is 0.9. Oh, I see. So hang on a second. So we render a fragment at point P, got this one, which we have to determine whether it's in shadow. To do this, we transform P to the light's coordinate space using T. So that must be this. Projected coordinates using the light's coordinate space. And then we divide it by W in case it's a perspective, but we're using orthographic right now. Okay. So that should actually be really simple, shouldn't it? So yeah, basically we've got the projected coordinates. This is the UV. The stored depth is this. Current depth, what is this? Why is it multiplied by 0.5 plus 0.5? Well, let's just keep going. I understand this so far. Using point P, we can also index the depth / shadow map to obtain the closest visible depth from the light's perspective, which is at point C, with a sample depth of 0.4. Since indexing the depth map returns a depth smaller than the depth at the point P, we can conclude that P is occluded and thus in shadow. Shadow mapping therefore consists of two passes. First, we render the depth map, and in the second pass, we render the scene as normal and use the generated depth map to calculate whether fragments are in shadow. It may sound complicated, but as soon as we walk through the technique, step by step, it'll likely start to make sense. The depth map. The first pass requires us to generate the depth map. Okay, hang on. The depth map is the depth texture as rendered from the light's perspective that we'll be using for testing shadows. Because we need to store the rendered result of a scene into a texture, we're going to need frame buffers again. First, we'll create a frame buffer object. Okay, well, we're doing something a little bit different. This is interesting. So they've got a 1024 by 1024 shadow map here. I'm using the same size as the camera at the moment. I wonder if that's going to be a problem. That might be a problem, actually. Generating the depth map shouldn't look too complicated because we only care about the depth values. We specify, yeah, okay. So basically that corresponds to, in Vulkan, we've got the sun's depth pass here, which is basically the same thing. So we begin rendering, we're using shadow map width and height. We're rendering using a depth attachment, but there's no color attachment. And we just draw the scene as usual here. Draw indexed. I think that's correct, yeah. Cool. So that gives us the result. And there you can see at the top there. Now the thing I'm a bit worried about is the shadow width and the shadow height. They've done it as a square. Is that important? Hopefully we can find out if we keep reading. I know in games, when you set the shadow resolution, it's usually, 512, 1024, 2048, or 4096, or 8192, 2K, 4K, 8K, etc. Texture. 16K textures, I think, as well. These days, so maybe there's a reason besides the math is faster. I know that much, but maybe there's a reason in terms of the way the shader is written that it's important for it to be a square. Let's see if we can find out. Let's see. When rendering the scene from light's perspective, there is no need for a color buffer. Okay, good. That's fine. With a properly configured frame buffer that renders depth values to a texture, we can start the first pass, generate the depth map. Okay, that's all well and good. This code left out some details, but I'll give you the general idea. So first we bind the frame buffer, clear the depth bit, configure the shader and matrices, render the scene, then unbind the frame buffer, and then render the scene as usual. Okay, that's fine. This code left out some, What's important here is that the calls to GL viewport, because shadow maps often have a different resolution compared to what we originally rendered the scene in, usually the window resolution. We need to change the viewport parameters to accommodate for the size of the shadow map. If we forget to update the viewport parameters, the resulting depth map will be either incomplete or too small. Okay. That didn't really give us a reason as to why they're usually a square, though. Okay, light space transform. This one's important. We need to understand this. An unknown in the previous snippet of code is configure shader and matrices. In a second pass, this is business as usual. Make sure proper projection of view matrices is set. Set the relevant model matrices per object. However, in the first pass, we need to use a different projection and view matrix to render the scene from the light's point of view. Because we're modeling a directional light source, all its light rays are parallel. For this reason, we're going to use an orthographic projection matrix for the light source where there is no perspective deform. Okay, fair enough. So they've opted for a near plane of 1 and a far plane of 7.5. Yeah, okay. Here's an example. Orthographic projection matrix, because the projection matrix indirectly determines the range of what's visible. You want to make sure the size of the projection frustum correctly contains the objects you want to be in the depth map. When objects or fragments are not in the depth map, they will not produce shadows. That's fine. To create a view matrix to transform each object so they're visible from the light's POV, we're going to use the infamous glm lookat function, this time with the light source position looking at the scene's center. Okay, that's all well and good. Combining these two gives us a light space transformation matrix that transforms each world space vector into the space as visible from the light source, exactly what we need to render the depth map. Okay. So if I have a look at the code that we have here, we do have a light space matrix, and we are sending it in to the sun uniform buffer. I just called it sun instead of directional light. So the sun uniform buffer is attached to the default pipeline, but I think I'm also using it on the depth buffer pass. Apparently not. So sun depth only pipeline is here. Okay, interesting. All right. The depth only pipeline is definitely creating a depth map because I can see it on the screen. And then what are we doing with it? That's the thing. So we're attaching the sun depth buffer image view. Okay. But what about the uniform? We push constants. Push constant. Let's have a look. Depth only. Takes, okay, takes view, projection, and model. And MVP times PVM. That should be fine, I guess. The sun push constants are PVM, MVP. Yeah, that's correct. So that's fine, I suppose. No problem there. So we're not actually using that other uniform buffer in this shader. We're just using the push constants. That's okay. So we've got this, and we're sending it in. That's all good. We only care about the depth values and not all the expensive fragment lighting calculations. So actually just using an empty fragment shader, like this. That's all good. Okay. The empty fragment shader does no processing, and at the end of its run, the depth buffer is updated. We could explicitly set the depth by uncommenting its one line here, but this is effectively what happens behind the scenes anyway. Okay. Rendering the depth / shadow map now effectively becomes this. All right. Now the result of their shadow map looks like this, which is similar to what we had before I inverted the colors here. So if I comment out these lines here, we have something similar to that. The program is open. All right, something similar. Although remarkably a bit different, isn't it? So that looks like, that looks 3D. I mean, I don't mean 3D. I mean, that looks like the outside of the objects. Whereas my map, I noticed, looks like the inside of the objects. So, could be a problem. Also, it doesn't seem to capture the top of this pillar at all. I've got some hotkeys set up. Let's see if we can adjust the view. So this is setting the far plane. I'm setting it lower. Okay, and we're just cutting off everything, I guess. Okay, setting it higher. And if I set it too high, for some reason the far plane starts cutting off the image. I don't know why that makes sense, because the far plane on orthographic projection should just be, you know, you should just be able to go as far as you want without changing the image. because I'm not changing the near plane. I don't get that. Don't understand. Although I guess technically you'd be sampling further away, and then eventually the difference becomes a floating point. No, I don't think that's what's happening, because it gets cut off sharply here, as if it's being cut off by the near plane, which doesn't really make sense to me. Well, if I move the near plane closer, now it's the near plane is further than the far plane, which doesn't make sense either. If I move the near plane back, and we get cut off again, as before. If I expand the size somewhat. Yeah, it's kind of interesting. I can't seem to actually capture the top of that pillar. The sun is up there. So if I go to the sun's position, I look down. It really... oh, maybe that does look right. Yeah, I guess from this angle, that would look correct. Yeah, okay, never mind. That's fine. I think maybe just the faces being clipped on the inside. I mean, culled. It's a bit weird. So if I go to cull mode for the not default pipeline. Wait, was that 2 default pipelines? Default pipeline, default pipeline. Okay, that's wrong. What is this pipeline? Debug. The depth converter pipeline. Depth converter, shadow debug. No, that's the one that draws the depth map on the screen. That's not the one we want. The depth only pipeline for the sun. That's what we want. So if we go here, we've got cull mode back. What if we change it to front? Okay, I think that looks better. Yeah, I think that looks better. Let's try expanding it a bit. Yeah, that looks better, I think. Kind of hard to tell. Maybe I'll invert the colors again. Well, yeah, that looks good. Okay, that's good. That's promising. So we've got something that looks kind of like this. Ours is inverted. Now, for rendering the depth map onto a quad, we use the following fragment shader. That's kind of what I was just editing. Rendering the shadows. Now, with a properly generated depth map, we can start rendering the actual shadows. The code to check if a fragment is in shadow is quite obviously executed in the fragment shader, but we do need the light space transformation in the vertex shader. Okay. So what's new here is the extra output, which is this one, frag pos light space. We take the same light space matrix used to transform the vertices into light space in the depth map stage, and transform the world space vertex position to the light space for use in the fragment shader. That makes sense, yeah. The main fragment shader we'll use to render the scenes, yeah, etc., etc. Okay, so let's have a look. See if we've got this first. So we've got the frag pos light space. I think it's in here. That would be this. Out frag pos light space equals light space matrix times the out position. Why did I use that? What's the frag position? Frag position is model times position. Okay, yeah, no, this is the same. I think, let's see, let's just double check. So frag position is vec3 model times vec4 a pos 1. So that's this one. Out position. Now out position is here. Yeah, that's the same. We don't have texture coordinates, so that's a bit different. I'm passing stuff when I could just use it, I think. So instead of passing these, uSunPos and uPlayerPos, could just use them directly. In here, if I get the binding, and we'll just put it here. Actually, I'm going to put it there, binding 2. And now I've got to go back to main and change it to, where is it? Is it this one? No, default pipeline, uniform buffer is available in the vertex and fragment shader. There we go. I think that should work. I think that's fine. Okay. Oh, that's interesting. We got a different looking thing going on here. All right. So I guess. All right. I'm not sure what's going on, but that's fine. So actually, I got to change this. So we were passing in. Yeah, that's what happened. The player position and the local normal. No, not local normal. What did I just get rid of? The sun position. Sun position and the player position. So I'm just going to get rid of those. Sun position and player position. And I will Coded Studio, hello, how you doing? I will actually just temporarily set these here. In sun pos equals so that the other code doesn't have to change. So hopefully we can build the shaders now. Yep. Okay, have a look. So kind of back to what we had before. So directional light is working. Point lights are working. Shadows not so much. So what's next? All right, the main fragment shader. Whoa, what happened? The main fragment shader we'll use to render the scene uses this lighting model. We can calculate a shadow that's either 1 when the fragment is in shadow or 0 when not in shadow. Then multiply the diffuse and specular components by this shadow component. Because shadows are rarely dark due to light scattering, we leave the ambient component out of shadow multiplications. Okay, fair. Okay, so getting up to the point that doesn't seem to work for me. So I've got this shadow calculation that's using the frag pos light space, which was this thing. Okay. So if we go down to our code here, shadow is here, and I'm using in frag pos light space. Okay. All right, and then ours is reversed, so we don't have to do that, but that's fine. Maybe we should just copy it right now. So we don't actually have the interior of this function, but let's see what the theory is. The first thing to do is to transform the light space fragment position in clip space to normalize device coordinates. When we output a clip space vertex position to GL position in the vertex shader, OpenGL automatically does a perspective divide. Okay, e.g. transform clip space coordinates in the range -WW to -1, 1 by dividing x, y, and z by the W component. As the clip space is not passed to the fragment shader through GL position, we have to do this perspective divide ourselves. Right. Okay, yeah, we got that. Because the depth from the depth map is in the range 0 to 1, we also want to use projected coordinates to sample from the depth map. We transform the NDC coordinates to the range 0 to 1. Okay, so I think this is where the problem may be. With these projected coordinates, we can then sample the depth map as the resulting 0 to 1 coordinates correspond to the transformed NDC coordinates from the first render pass. This gives us the closest depth from the light's point of view. Okay, so let's see. Vulkan NDC. Oh, I was hoping it would just be a page. Vulkan's NDC is right-handed. Yeah. So X to the right, Y down, and Z to the screen. OpenGL is left-handed, but why is Y down? Right-handed doesn't make Y down, does it? Okay. What does this say? For OpenGL flip control for Vulkan, the NDC space origin can be made lower left by passing a negative height value when setting the viewport, and the depth range can be made -1 to 1 by setting pipeline viewport depth clip control -1 to 1. Oh, I see. So we don't actually need to do this. We just need to convert, I guess, from 0 to 1 to -1 to 1, I think. There was something else that I saw today. Where was it? Was it this? Yeah, so this Anki 3D Engine dev blog. Right, so this guy says, first thing to note is that Vulkan requires right-handed NDC space compared to GL. In other words, the -1 to 1 NDC coordinate maps to the top left corner for Vulkan and the bottom left for GL. In practice, if a Vulkan application ignored this convention, the final output will end up flipped in the y-axis and inside out. That sounds bad. Basically allows negative height in the viewport structure. In practice, this allows us to flip the viewport in the y-axis during viewport transform. Okay. Final piece of the puzzle is what happens when drawing onto the swap chain images. Unlike off-screen rendering, the front face is not changed, but the viewport's height gets negated, and that will cause a flip. Okay. Vulkan not only expects right-handed NDC space, but it also requires that GLFrag chord's origin to be at the top left corner as well. GLFrag chord's origin is configurable in GL, but SpearV doesn't allow us to move it to the bottom left corner. The SpearV specification has some wording in place for a bottom left origin, but at the moment it's an error to use it. The fact that off-screen render passes are logically flipped helps us work around this limitation. This is the code that changes the front face, and it's not configurable, and it's always counterclockwise. Okay. That's a lot to wrap my head around right now. So, the next difference between the two APIs, I'll just zoom in a bit here if I can, is the Z range in NDC space. By GL, using a typical GL projection matrix, ZD ends up in -1 to 1 after the perspective division, just like X and Y. The viewport transform for the Z component is given by this equation. The F and N are the near and far limits, and they're typically 0 and 1 respectively. So the equation above gives a new range in 0 to 1, and that's the depth value that will be used for depth testing and will be stored in the depth buffer. The fact that GL expects ZD in -1 to 1 gives some kind of consistency since all three components, x, y, and z, end up in the same range. One interesting property of floating point numbers in the 0 to 1 range is they have better precision closer to 0. This has an interesting impact on the accuracy of depth buffer. For GL's range, it practically gives okay accuracy close to the near plane. The best quality is somewhere close to camera Z depth equals 0, and worse, close to the far plane, Z depth equals 1. Okay. Vulkan and Direct3D using another convention where it expects ZD in 0 to 1 range. So the viewport transform for the Z component is given by this equation instead. Max depth minus min depth times the depth plus min depth. So it's typically 1 and min depth is 0. If ZD is mapped in 0 to 1, then depth will be 0 to 1 as well. Yeah, that's what I got. Having a common system for depth for both GL and Vulkan is a bit tricky, but there are two solutions. The first is to use GL's convention for both APIs and append this at the end of every Vulkan vertex shader. GL position Z equals GL position Z plus W divided by 2. Okay, so that's going to map it to 0 to 1. Is that right? So what if I do that? At the end of every Vulkan vertex shader. So would that include the depth shader, or would it just be this shader here? Wonder what's going to happen to the rest of the scene. Well, the rest of the scene looks fine. Did that not compile? I have a feeling it might not have compiled. No, it did. Just didn't seem to change anything, which is a bit weird. Okay. Huh. Maybe I misunderstood what this meant. Are we even using it though? I don't think so. The second solution is to use Vulkan's convention and use the clip control extension to move GL to what Vulkan prefers. After all the projection matrices are mapped to map the Z buffer to a new range. Okay, change the shader code that unprojects depth to view space Z in Anki. There were quite a few places that do that. Align the software rasterizer to use a new system. Okay. Well, this is cool. Still don't know if this is exactly my problem. It looks like it might be a problem. So this guy has the same solution here. Interesting. How can I test this? So if I pre-multiply the projection matrix by the following correction matrix, the resulting corrected projection matrix is mathematically equivalent, but does not require the additional GPU overhead. So 1, -1, 0.5, 0.51. Okay. Am I even looking at the right problem? Whoop. Whoop. Okay, well, let's just go down here and have a look at this. So calculate shadows. So this is gonna I just want to know what these values are directly. Can I see that somewhere? Maybe in render doc. So if we have a look at the color pass here, not that one. Wait. Oh, it's inputs. Okay, so the output is this. Pipeline state. I want to look at the fragment shader. There's a sampler with this attachment. I want to look at the contents. Where is it? Okay. I want to change this to... what the hell? Floats. Okay, so it's all between 0 and 1. That's what I would have expected. Okay, that's fine. Now what I might do is... so that's the... Wait, what was that? Oh, no, that was the wrong thing. I want the... No, that is the depth attachment. Okay, so the depth attachment is what I would have expected, between 0 and 1. Right. That's all good. Okay. So the thing that I want to figure out is what does this resolve to? This here, current depth. Projected coordinates Z times blah, blah, blah. And how can I do that? I could write it to a texture, I guess. Yeah. I think that would work. How do I do that? Layout. I could just write it to a buffer. And this could be vec3 array of how many? 1920 by 1080, I suppose. Is that going to be too many? No, I don't want vec3. I just need pixel. I just need float. Okay, and then I can say, how do I get the coordinates? I guess it would be this, right? X, Y. No, it would be frag coordinates. I think it's this. Geofrag coordinates dot xy. It would be dot y times 1080. No, times 1920. Plus dot x equals current depth. Okay, I think that would work. Let's see if I got an error. I did. Can't modify uniform. Oh, this needs to be storage. I think it's called. It's not called storage. What is it called? Okay. I want to see in the shader. Here it is. Okay, object data, read only, uniform constants. Right, okay. So I guess it would be buffer. Okay, there's a problem. GL frag coordinates is not a thing. Really? What is it called in Vulkan? Oh, is it GL underscore frag coordinates maybe? Still not a thing. I need a manual about GLSL for Vulkan. Yeah, me too, actually. Is it frag coord? All Vulkan related changes to GLSL are documented here. Okay, great. Cool. It is frag coord, not frag coords. I suppose that makes sense. Okay, so scale integer expression required on line 61. Okay, can't do this multiplication here. I don't think I have to say how many there are. It's gonna say it's an array. Right? No? Oh, different line. Oh, this line. Okay, fair enough. Maybe this was fine. I'll just leave it. Whoops. Okay, compiled. So, we're gonna make this binding now. So it's binding. I can't do binding 3, I think. No, I can do binding 3. Okay, binding 3. Storage buffer. Descriptor count equals 1. It's just the fragment shader. Binding 3. Now I've got to go down here and make it. Do I need to know the size? I guess. Let's see. Create buffer. I'm just going to copy this. It's a lot of text to write. Create debug storage buffer. Change everything in here that says sun uniform can be debug storage. Okay. And this is going to be size of float, no, F32 times 1920 times 1080. Maybe I should, yeah, that's fine. Just leave it like that for now. And it's not a uniform buffer, it's a storage buffer. Yep. Okay, host visible, host coherent, yes. That should be good. Now, I got to... I guess I don't need to do anything else, because it's going to happen in the shader, and then I can check in render doc. Okay, hopefully that works. Let's see. I feel like I missed a step. Whoops. I want to open in render doc. Launch. Alright, so it was in the color pass, and we got a few things here, some outputs. Okay, what else is here? Debug output, here it is. So I need to look at this. Debug output. Okay. View the contents. Okay. Apparently it looks like nothing because it's not bound. Wait, what? Oh, here we go. We've got the values in here. Excelente. Okay, we're going to use floating point. Okay, apparently the value is very tiny numbers. Right. So negative 2.03 to the 38th exponent. Let me see it again. That was a... Damn it. Which one is it? This one? Right, so this thing. Pixels, 1920. Okay. This is weird. What is this? Like, what are these values referring to? Got a row of RGB normalized. Oh, it's normalizing them? Between 0 and 1? Okay. What if I get rid of that? Huh. Yeah, anyway, let's look at the actual numbers. So, this is like... The exponent means that the decimal point's very far, right? On the right-hand side. So these numbers are kind of nonsense. What are we filling it with again? Debug out. Current depth. So... What if we put in projected coordinates.z instead? And have a look at that. Wrong thing. Oops. Okay, we got the frame. And we got, where is it? Yeah, this thing. Right. One. It's just one. What the? Are we looking at the wrong buffer here? No, yeah, we're looking at the depth attachment. I want to look at this. Debug out. Oh, we can't. Is it because it's... What is up with this? It's used in these things. It's in layout, depth, stencil, attachment, optimal. What? Oh, that's this. Okay, I'm not looking at the right thing. That would be a problem. Okay, let's have a look. No resource. Read-write buffer. Okay, well that explains why the numbers didn't make any sense. So this doesn't exist because we didn't allocate memory for it. Well, we did. Vertex buffer, index buffer. What do we call it? Debug storage buffer. Here it is. It's the size of 1920 by 1080 float 32s. debug storage buffer size, which we use here to allocate. Okay. Okay, what's the problem? The problem is the descriptor set is not updated. I should have read the Vulkan warnings. It would have told me this straight away. So yeah, right descriptor set. We need why am I writing this out manually again? It's just a habit. Okay, the binding is 3 and it is buffer. And we need buffer info. There we go, buffer info, and this is going to be uniform. It's debug. What was it called again? Damn it. Debug out buffer? No. It's right here. Debug storage buffer. Alright. Right. So I'm going to compile this and run it and look at the Vulkan output first before I do anything. Yeah, okay, what have we got? Descriptor sets. Set as a type sampler, but the image info is null. Right. Whoops. Because I copied it. It's not... what? Where's the sampler? No, I didn't set the type. Yeah, right. So descriptor type is storage buffer. There we go. Okay, it's running and there's one error. Binding 3 debug output. Right, it's not marked non-writable, but fragment stores and atomics was not enabled. Oh, okay. Then all storage image and storage textile buffers and storage buffer variables in the fragment must be decorated with the non-writable decoration. I see. Fragment stores and atomics. Okay, what is that? It's physical device feature. Right, okay. Where is that? Physical device features, where are they? Okay, here we go. Physical device features. I thought there was a list that I put somewhere. Where was it? So we've got here it is. Here. Yeah. Okay. What was it called again? I think I have it on the clipboard. Fragment stores and atomics. Wait, no, it's a physical device feature. It's probably here. Okay. Hopefully that. Okay, that seems to work. Now we can have a look at render doc. I think it was just worried because it could be clobbering your data, but since we're setting the pixels to the correct position, hopefully in the texture, then it shouldn't matter. I mean in the buffer, not the texture. Well, we might have a problem again. No, we got one. Yes, buffer. Here's the buffer. We can finally look at the contents. Alright, so it's mostly zeros. In fact, it's zeros forever. Well, no, not forever. Okay, I'm gonna maybe have a bunch of floats going along here. Let's say 5. What? Okay, I'll just do vet 4s then. So we get a little bit more on one page. I should expect these to not be 0 at some point, but maybe not yet. So that would only be what? 10 pixels down? We've got 500 something pixels to go. So maybe we should go to like the middle. What would that be? 4 million? Something like that. Hello? Is this 4 million? Doesn't look like it. Oh, there we go. Here's 4 million, right? There we go. There we go. Okay, so there's some data in here. That's what we wanted. Okay. So we've got values that are between 0 and 1 already. Yep. Okay, so I don't see why we should halve these and then add 0.5. They are quite small values. None of them are really going above 0.2. Is that expected? Maybe. Maybe there's a way to view non-zero values, actually. Maybe what I should have done is kept an atomic counter of how many I've written out and then only write out non-zero values. I think I can do that. I can't remember exactly I think it's atomic int or something. Vulkan GLSL atomic int. Okay. Vulkan doesn't support them because they're a distinct hardware concept. Oh. Oh, interesting. Well, what does this say in the Vulkan guide? Something about atomics. To better understand different extensions, exposes blah blah blah, features for atomic operations. Okay, an application is allowed to use 32-bit int types for atomics. This can be used for all supported SPIR-V operations. Okay, then that, whatever that guy was saying was just wrong. Or maybe he's talking about something else, I don't know. That's cool. Okay, so I need... That's fine, I don't need extended support. I can just use a 32-bit int, that's okay. Can I? Actually, because it's like 8 million, not 8 billion. Yeah, that should be fine. Yeah, I don't want to expand it. I just want to see how you write them. Okay. Well, that doesn't really help. Problem with atomic operations on Reddit, eh? Atomic exchange, temp 1, or crash. You can only use them against SSBOs and images. Right, okay. Maybe this is just the wrong way to think about it. That's fine. That is fine. Doesn't really matter. I'll worry about that another time. So it's just because the data is going to be all spread out here. I'm just trying to see if I guess I could export it. Yeah, let's do that. So export it to bytes. Binary file in my documents. Sure, why not? What would I call this? Depth buffer bytes, something. And then what am I going to do with that? Remove 0 bytes, I suppose. Remove sets of 4s. See, the thing is, these are going above 2. Okay. Let's just go maybe to the 6 million. I can't go to 66 million. It's not letting me for some reason. Alright, that's fine. 6000. Oh, because it's vec4s. Right, okay, so divided by 4. So 2, something like this. 250,000, 2,500,000. Yeah. Is that right? Huh. Alright. Well, the point is, I already have depth values in here, right? So they already exist. So multiplying them by 0.5 and then adding 0.5 doesn't seem to be useful for this. Let's see what happens if I just delete that. Huh. Interesting. We have inverted shadows by just deleting that part of the code. So if I invert this, what happens? We have sort of shadow. Interesting. Right. I think. Well, that's good. That shadow works over there. That's pretty cool. See? Yay, shadow. This one is a bit messed up. I think it could be because I need to cull the front face. In the sun depth pipeline, here it is. I'm already culling the front face. Okay, what if I call the back face? What's going to happen now? Hey, look, shadows. So the problem was, as far as I understand, there's a coordinate mismatch between Vulkan and OpenGL, and they added this in the shader to this part here. I think they did. Let me just double check the shader. Maybe I just added it and made a mistake, which is entirely possible. Yes. It looks like I added it and made a mistake. And so that was totally my bad. So basically this line was wrong. Huh. And that was the problem the whole time. And it took making an output buffer and looking at the numbers in RenderDoc to realize that was the mistake. But, you know, that's alright. I'm okay with that. Because we got there in the end. Also, this didn't seem to do anything, so I'm just going to delete it. But maybe it did do something, but I just don't know what. Okay, so we got shadows. We got the problems that come with shadows, which is you can see a little bit of light bleeding. So we're going to have to add something called... Man, the shadows look pretty... Oh no, they look pretty crap. Yeah. Yeah, pretty crap. We're going to have to add PCF, I think it's called, which is something filtering. Point something filtering? I can't remember. Well, we'll check it out in a second. I'm just going to grab some water. All right. Very good. Very, very good. All right, that's great. I can't believe that was the problem the whole time. Well, at least now I understand how this works, which is a much better situation to be in than having it work and not understanding anything. Where is the noisy texture coming from? It's coming from this get terrain color. So it's just calculating based on the normals a little pixel grid that's like 1/16 of a meter. It's really not great, but I just didn't want to have flat color. I liked a little bit of noise. Your name is very familiar, Arxiv. Why is that? So if you did things right, you should indeed see shadows on the floor. I do. I don't have the artifacts like this, but... Oh no, I already added this part, the bias. Yeah, right. Okay, that's all good. Now the next part is... Oh yeah, whoops. Damn. Peter Panning. Where is that? Oh, go away, please. You're around, and also it's a website. Oh yeah, it's a papers website, isn't it? For looking at where people publish things. PCF. So we'll do PCF first, and then Peter Panning second, maybe. Disadvantage of using shadow bias is that you're applying an offset to the depth of objects. As a result, the bias may become large enough to see a visible object of the shadows compared to the actual object locations. Let's have a look, actually. Well, actually, I'm going to stop the scene from moving first. Let's just comment out that line. And I guess we should... Actually, we should rotate it a little bit. So I'm going to do like a 0.45. What's wrong with that? Oh, doesn't know whether to use an F45. Yeah, there we go, F32. Okay, so looks a tiny bit... I guess that's what this is, right? It's a tiny bit off the edge there because of the biases. Alright, let's have a look. They seem slightly detached from the shadows. We can use a little trick to solve most of the Peter Panning issue by using front face culling when rendering the depth map. You may remember from the face culling chapter that OpenGL by default culls back faces. Yeah, I already did this, I think. Didn't I just do that? Sun depth buffer, sun depth only pipeline is... Yeah, I'm using back face culling. I use front face culling, the shadows don't work properly, which is interesting. If I look at the map, that looks good, but the shadows look not good. I'm confused about that. Could be my face direction is clockwise. I think most people assume counterclockwise, right? Maybe that's a problem. Yeah. See, that looks weird, but the shadows look better. If I do no culling, then I think the shadows look really funky. Oh no, they look better. That looks much better. Okay, I guess I just won't use culling on the depth pass then. That might be expensive later, but for now, that's cool. Okay, oversampling. What's oversampling? Is that regions outside the light's visible frustum are considered to be in shadow while they're usually not. This happens because projected coordinates outside the light's frustum are higher than 1 and will thus sample the depth texture outside its default range of 0, 1. And based on the texture's wrapping method, we get incorrect depth results, not based on the real depth values from the light source. Okay, well let's have a look and see if we can simulate that by using our rectangle construction thing that I got here. So this one is at position 0, and we're going to make it huge. It's going to be 100 by 100. That's kind of the ground thing that we're looking at. Oh yeah, so that's the cutoff of the projection over there, and you can see it's just totally in shadow. Yeah, that's not good. So how do we fix that? Let's have a look. Hang on. Yeah. Yep. So based on the texture's wrapping method, we'll get incorrect depth results, not based on the real depth values from the light source. You can see in the image there is some sort of imaginary region of light, and the large part outside this is in shadow. This area represents the size of the depth map projected onto the floor. The reason this happens is that we earlier set the depth map's wrapping options to repeat. What we'd rather have is that all coordinates outside the depth map's range have a depth of 1, which as a result means these coordinates will never be in shadow, as no object will have a depth larger than 1. We can do this by configuring the texture border color and set the depth map's texture wrap options to clamp to border. I see. Right. Isn't that also an issue? There still seems to be one part showing a dark region. These are coordinates outside the far plane. You can see that this dark region always occurs at the far end of the light source's frustum by looking at the shadow directions. Okay. Is that the case for us? Yes, that is probably the far plane. Actually, I can modify the far plane in real time. Let's make it further away, closer. Well, making it further away breaks the shadows. How does that make sense? Make it make sense. You can't. I gotta understand that at some point. It's so weird. Anyway. Yeah, okay, cool. That's fine. So the fix for this is relatively easy, as we simply force the shadow value to 0. Oh yeah, so I have that, except oh no, I had that. I don't have that anymore. Okay. If the Z is greater than 1, then set it to 0. Okay. So this is going to be shadow equals return shadow, and then if actually I could just early exit up here. If current depth greater than 1, return I think I return 1. No, das ist not correct. Okay, that also didn't work. Interesting. What's the problem here? Checking the far plane and clamping the depth map to manually specified border color solves the oversampling. So I think I need both steps. Alright. So the first step was this, clamp to border. So I'm using... Where did I make the texture? Is it this one? Debug storage buffer. No. Is it this one? What is this one? This is the default graphics pipeline, and this is the default depth sampler. This is the depth visualization pipeline. No. Wait. Okay, it is this one, I think, actually. Yeah. This one. We've already got it on clamp to edge. Clamp to border. Is that a thing in Vulkan? Clamp to border. Okay, that is a thing. Okay. And border color. Where do I even set that? Is that on here? Yes. Border color equals float. Is it going to be float 32 like this? No. Okay. What is this type? Border color type. Oh. Opaque white. Okay, I'll just set it to a 4 then. I shouldn't set it to 4. I should set it to opaque white. There we go. Float opaque white. There we go. That will do. Hopefully. Wow. That looks good. Right? Oh, still got a problem over there. Still a little bit in shadow, but that could just be that the world is being cut off. Oh no, yeah, that's the problem. Okay. So maybe the fragment shader. Where is it? Okay, maybe it was going to be supposed to be 1. Yeah, there we go. There we go. Wow, would you look at that? Starting to look like a real 3D scene. That's amazing. What happens if we change from these random rectangular prisms into a real model? So I'm just going to comment out this part and uncomment this line and have a look. Alright. Yeah. Nice. Oh man. Whoa, is that frame lag that I'm getting? That's crazy. Already getting frame lag. For real. Well, it definitely looks better. Interesting that... Oh, the model's rotated, right, yeah. I rotated the model by sine f32 0.45. I'm going to unrotate it. Yeah, that's what I was expecting. Whoa. What's the lag from? Let's find out, shall we? Yeah. Wow. Only 60 FPS. That's really bad. That's crazy. We're not even doing much. Although I guess we are writing 4 million float values to a buffer every frame. That could be a problem. Or is it 8 million? It's 8 million, yeah. Maybe if we don't do that in the fragment shader, then it'll be a little bit better. Let's have a look, eh? Yeah, okay, now it's frame locked at my screen's FPS. That was probably the issue, doing 8 million writes to memory every frame. Cool. That's good. Everything is looking fantastic. I mean, it's not looking fantastic yet, but it's definitely on the right track. I don't really need to look at anything right now. but I am going to commit this as a bunch of changes because I don't want to. I hate this. So I stopped using Odin format because I just wanted to format stuff my own way. But my editor, well, I guess it's me. Sometimes I leave these new lines. It's something I really hate about Helix. It'll add spaces at the beginning, even if it's not, even if you didn't type anything, it doesn't delete them for you. Maybe you can change a setting for that. I don't know. Like that one. Ugh, disgusting. Okay. That's all good. We didn't add PCF yet, so I'm just going to say there's a lot of stuff here, but what are these called? Directional shadow implementation. I feel like I should write more, but I don't know what to write right now. That's fine. Okay, so we're getting there. We got shadows. They look a bit jank because that's just how it works, I guess. Because of the way the sample's up. We've got some light bleeding in here, which is not great. So probably have to fix that. Is that monospace Comic Sans? Yes. Yes, it is. Jonas says you have a thing for trimming trailing white space on save in your editor. Don't know about Helix. Yeah, surely there would be an option, right? Helix, trim, white space. Oh no. Would somewhat alleviate this issue. There's a macro. Yeah, it's called Comic Mono. It's pretty good, actually. I like it. It's, yeah, this one, I think. Yeah. Yeah, because I saw that it was an issue, and I know when I look up Helix issues, it's usually like, yeah, we're not planning to support that because of some weird reason, so you guys can just use an LSP or something. I like Helix a lot. It's got sane defaults. The Cocoon style editing is really nice, where you select first and then you do something with your selections. I think that's really good. But having an LSP to trim white space is pretty lame. Although I am using an LSP. I just turned off the auto formatting. Whatever. It's not really a big deal. I mean, who cares? It's just some white space. It's just me on this project anyway, so it's fine. Cool. So that's all good. I still need to really understand more about this. I'm sure it's going to come back to bite me. The left hand versus right hand. I mean, yeah. Left hand. Right hand. Makes sense, but why is Y going down? Yeah, well, that's fine. Or is it like this? Left hand. And then that's pointing back into the screen, yeah. Okay. Let us move on. There are a few more things. PCF is one of the things. Okay, that part's all good. Check the far plane and clamping the depth manually. Very nice. Here we go. PCF. This is it. So the shadows right now are a nice addition to the scenery, but it's still not exactly what we want. If you were to zoom in on the shadows, the resolution dependency of the shadow mapping quickly becomes apparent. Because the depth map has a fixed resolution, the depth usually spans more than one fragment per texel. As a result, multiple fragments sample the same depth value from the depth map and come to the same shadow conclusions, which produces these jagged, blocky edges. Well, I am actually going for a more of a jagged look with the game, so maybe I'm going to undo this later, but I should do it anyway just to see if we can get something different. You can reduce these blocky shadows by increasing the depth map resolution or by trying to fit the light frustum as closely to the scene as possible. Another partial solution is called PCF, which is a term that hosts many different filtering functions that produce softer shadows. It means percentage closer filtering, making them appear less blocky or hard. The idea is to sample more than once from the depth map, each time with slightly different texture coordinates. For each individual sample, we check whether it's in shadow or not, and then all the sub-results are then combined and averaged, and we get a nice looking soft shadow. So that's just like an anti-aliasing, but for shadows, I guess. One simple implementation is to simply sample the surrounding texels of the depth map and average the results. Yeah, okay. It doesn't look that good, but let's see if we can do it anyway. Okay, what do we got? So, there's some code here. Texture size returns a vector of the width and height of the given sampler texture at mipmap level 0. Okay, that's fine. Making sure each new samples a different depth value. We have 9 values around the projected coordinates x and y. Okay, that's cool. By using more samples and or varying the texel size, you can increase the quality of the soft shadows. Great, okay, right. Let's have a look, see if we can put this into action. Alright, so this is just going to be in the simple 3D fragment shader, which I should probably rename because it's no longer simple 3D, it's got all the lighting in there. But anyway, that's fine. I was thinking maybe I'll split this out into another shader at some point, but that is for another time. So here we probably, we just want to return early. Then we say shadow equals 0 and a texel size is 1 divided by texture size of the shadow map. So yeah, I need to grasp what a texel is exactly. It's like a texture pixel or something, but what does that mean? I think that's a very important step for graphics programming. What is with this loop? X equals -1, x less than equal to 1, plus x. So 3 by 3? Oh, I guess it's so you don't have to do the math here. Alright, I guess that's fine. Plus x means we're going to increment. Why plus x? Doesn't matter, I don't think. It's just a stylistic choice. Just like mine. Actually, I have a reason for using plus equals 1. I have a rule that plus and minus are only for pointer arithmetic. And any numbers need to use plus equals 1. Shadow map, projected coordinates. Yeah, so that's the things we just got. Plus xy times texel size. Okay. I like to map this out somehow. Okay. Right, and then divide it by 9 because that's how many we did, right? I don't think you need. I gotta look that up as well. There's so many decimal points in everyone's shaders, and I don't know if you need them. Because like this is already a float, so obviously you can't integer divide a float, so it's not going to convert this to an integer and then do an integer divide and then convert it back to a float, right? That would be crazy. Although maybe I shouldn't make assumptions like that. Yeah, so the bias we got to calculate up here. And then I'm just going to return shadow here. I should build it in this tab so I can see if it fails. It did, yeah, because I missed a semicolon. I always miss semicolons. I'm so used to Odin. Where is it? Where do I need the semicolon? What? Unexpected semicolon. Oh no, I put an extra semicolon. Wow. Right here. I didn't put the 1. That makes sense. Okay. Corrods. Yeah, that's not correct. Swizzle out of range because it didn't exist. There we go. Okay, that's definitely not... No, that's definitely not good. That's very not good. What the hell is that? Alright. I am gonna have a look at the example, because I definitely messed it up. Let's have a look. So this is the shadow mapping fragment shader. So they've set shadow as 0, right? Texel size is 1 divided by texture size of the shadow map. What does this second parameter do? I don't know. Texture shadow map texture coordinates plus times texture size dot r. Okay, correct. Shadow plus equals current depth minus bias greater than PCF depth is 0 or 1. Yeah, I'm pretty sure. Alright, I'll put this down here. If projected coordinates. What's the point of this? Like, he sets current depth here, and then uses projected coordinates here. I don't know. If one operator is in a division if one operator in a division is a float, it converts both to a float, right? That would make sense. Okay, we got a very different result from moving this down here. That's all I did, right? Interesting. This happens after the loop iteration, so we don't have to... Oh, we do. That's why. You can't sample... Oh wait, no, -1. No, that shouldn't matter. It doesn't matter. I'm going to test it anyway, but I'm pretty sure it doesn't do anything. Yeah. No, I was having a brain fart there. So that happens after each iteration, so it doesn't matter what order you increment. Like if you increment first or post or pre, I mean. So texel size... Man. Is this some kind of problem? Shadow is 0. Okay. Then we're going to divide it by 9 eventually. I'm going to add these. I don't think it's going to do anything. Also, I mean, those are very straight shadows, so I can't really tell. And these are not at all blurry. They're kind of round, actually. It's a bit weird. So, this needs to be reversed because the way that we do our addition, yeah, that's better. But this is not doing anything, and it's also wrong. Huh. What did I mess up? Let's see. So they got projected coordinates. getting the store depth, which is the closest. Current depth, yeah. Then if one dividend or divisor, yeah. So I guess you could say one term, or that's the math. I think that's the math term, and then the programming thing is what is it? You got a binary operation on two what expressions? That's not. There's another word for it, but yeah, I get what you mean. Okay. So their bias is pretty much the same. My normal's already normalized. I'm pretty sure. Although I'm normalizing it here, so maybe not. But I'm normalizing it here anyway, so it doesn't matter. So dot product between normal and the light direction. Our bias is much smaller. Maybe I should change that. Okay. This is still really messed up. That's totally incorrect. It's kind of interesting, huh? Considering it was just working. So if I comment this out, and I uncomment this, and I comment this, what do I get? I get... Actually, it wasn't working. I thought it was, because it's working on the floor, but this should not be in light, right? Oh wow, that's really zoomed in. Okay. So that's a bit of a problem here. So we're gonna, let's just make this a bit smaller. There we go, something like that, and then we will increase the far plane. But if we increase it too much, it breaks everything. This is really finicky. Like that doesn't make sense. There's nothing up there with that pattern. That's coming from where? So if we adjust the near plane, where's the sun again? Up there. So I'm gonna go to the sun. So basically, the only part that should be in sunlight is this balcony here, pretty much. Although I guess technically the angle, yeah, pretty much this balcony. Maybe because the angle is it's orthographic, right? So maybe, yeah, that side of the, yeah, that's that side of the bottom walkway as well. So the problem is that we have our, well, I think the problem is we've got this orthographic projection set up for the scene, but our last scene was much smaller. So if I actually recreate the game here, you can see I've got scene bounds here. So the size is like 30 by 12 by 18. I think that's X, Z, Y. And this is really zoomed in. So I can zoom it out. Where is it? This key. Yeah, that key. This key zooms. Sorry, it doesn't zoom out. It makes the clip plane further away, the far plane, but this one sort of zooms out. So I'll zoom out to like 20. and then zoom out to like 20 on the other axis and see how that looks. Yeah, that's cool, but as you can see, there's no concept of blocking shadows from here, which is weird. So these ones block shadows. These curtains, they cast shadows rather, not block shadows. They block light. That's what I'm trying to say. These columns don't seem to at all. I'm going to make another little thing here that I can maybe fly around as the sun. That would be kind of cool, right? So if we go sun, there's a bunch of sun variables somewhere. Sun underscore h? No. This file is getting massive. It's like 2,200 lines now. It's pretty big. Here we go. Sunlight position, sun position. So sunlight direction. That's all cool. What if we could set this? So if I press Z, right now I'm just moving myself to the sun position. But what if I do something like this? stl.k_x move sun equals not move sun. I know this is a really stupid name, but who cares right now? It's just temporary. Move sun is going to be false. But then here, when I'm doing all this input stuff, where is the input used? Here. So we're going to move the camera position, but what if instead we say the moving position is going to be a pointer to a vec3, and then we move the some whatever that is, right? So whoops, camera dot position could be the moving position. Okay, and then if what's the problem? Is it because it's not a yeah. So this needs to be like dereferenced. Hey. Or actually I can make this a bit, I think I can make this a bit nicer. So this is actually going to be camera position, but if we are, what did I call that variable that I said was stupid? Move sun. Move sun, then the moving position is going to be the sun position. Wait, where is it? I didn't make it yet, I guess. Sun position. Yeah. Okay, and now at the bottom here, I'll just say yeah, that's all well and good, and we're just going to say the sun position, no, camera, I should put it here, camera position equals moving position, and that's actually if sun, move sun. Okay, I think we should be able to dynamically move the sun around now if I press the X button. Unless I messed something up there, which I probably did. Okay, press X. Oh, yeah, I can move the sun. But I'm not... I should have also made it so that I am looking from the sun's position. But anyway. It's kind of cool. Yeah, so let me do that. And in fact, I can make it orthographic projection as well, because we can set that here. So I can say if move sun, else this. So that's the camera projection, but we're going to look at view is going to be I'll do it after this. Mat 4 look at, what are we looking at? I guess sun position 0. So we're always going to look at the center of the scene. And then I'll set the projection to be this. Apparently that's not a thing. Oh yeah, it's VP. So VP. Wait, no, it is a thing. Projection. Mat 4 look at. There we go. So I'm also going to need to set it back to what it was before, which is if I look for perspective somewhere, which is this. MVP dot projection is this. Okay, I think that should be apparently not a thing. What's the problem? Oh, right. I'm trying to set it as a new variable. There we go. Okay, I think that'll work. Doing a little bit of extra math, but that's fine. So press X, bam. All right. We are now the sun. That's cool. Interesting. Well, moving is all well and good, but you know, that doesn't really change the angle now that I think about it. Oh, we can go up and down. Oh, I forgot about that. Okay, we'll go up and down. X, so I go up. Or is it up? No, it's down. Up. Down, up. I think that's up. Man. It's not a good view, huh? Okay, maybe I shouldn't have put it into that orthographic view. Although I guess it's more accurate. Oh, that's a bit better, I think. Right? I mean, it's much easier for me to understand what's happening, at least. So... Alright, okay. So, I'm not seeing... Well, obviously I can't see shadows because I'm the sun. The sun doesn't see shadows. Okay, I'm going to go back to the ground. And... Okay, that looks good. I think that looks actually correct. The sunlight's sort of coming down here. That's a little bit off. That's definitely off. And there shouldn't be light in there from the sun. Well, man, this is also incorrect. There shouldn't be light over here. There might be light here, that's correct. So that light is real light from the sun, that's cool. This light is all fake, incorrect math light. That light down there is real. These shadows look kind of real. So does that from this thing, but it's not really attached to it, which is a bit strange. So like, the shadow from this is not going up to it, which is a bit weird. Man, that's That's tough. Seems there's a lot of things wrong. I don't know if it's got anything to do with the model. I'm going to assume the model is correct, and that it has all correct normals and everything, because it looks like it does. You know? That's a bit weird. Well, the only thing I can think of right now is just to change the base position here. I'm going to change it to like, I don't know, some other, I don't know why I put a -2 there. It doesn't really change anything. Just put it slightly off on both angles so we get a little bit more of an interesting position. So this should all be in shadow, right? But it's not, because we're not getting enough of this. So I've just increased the minimum distance of the frostum. But then if I increase the max distance, it starts cutting off again. I don't understand this. Why would that happen? It doesn't make any sense to me. Right? Because I'll draw a little diagram. So imagine you've got, I don't know, let's just say some orbs or whatever. Some little orbs. Okay, and then this one's far away. I'm going to do an orthographic projection. Okay, so let's say we're projecting orthographically onto here. So you would expect it to look like something like this. And I would say, okay, this is going to just go really far back. And then we're going to project onto, you know, in between this. So this is the frustum. I don't understand why moving this back would affect anything visible. It should just stay visible if I move this back. Right? Doesn't that make sense? Unless this doesn't work how I thought it does. It looks just like near plane, far plane. Yeah, okay, that's cool. But you know, when I modify this value to be further away, why would it cut off anything in the front? It would just move this back. Like, let's imagine that it's here, and these are both, let's say actually the small one is behind the plane, but this one is not visible. Okay, and then we're like, okay, we want to make it visible, so we push this back, and we push it back, and we push it back. Why would this one get cut off at any point? I'm not really understanding that. Maybe there's some kind of depth parameter that I need to set to be larger. Don't know. And not here. So like, what is depth 1? Is that maybe a problem? Is that not deep enough? But then, if it doesn't go from 0 to 1, then you're going to have problems with all the... well, you have to normalize it, I guess, squash it back down, right? So the sun's depth buffer goes from 0 to 1. If I just change this value, what's going to happen? If I change it to 2, for example. Oh, I can't. It's not... it's still open, so I can't compile. Well, we got an error. Because it must be 1. Right? Yeah, that's what I would have expected. Because it doesn't make sense for it to be more than 1. Let's see, maybe Google has an answer. Why, when increasing ortho far plane does my near geometry get cut off? I thought... Yeah, let's just see if there's an answer. I really don't want this. I'm gonna uninstall this thing. Okay, so let's say I have a rectangle. I want to be render oriented at 45 degrees around the x-axis of the camera, so it looks like this. Clipped at the bottom only because it's the edge of the window. As I shift this rectangle along its local y direction, then it usually gets clipped by the far plane. How do I prevent this? It seems unnatural that the rectangle should be cut off at all when moved away from the viewport but still within actual view. I definitely do want to render my rectangles orthographically. And this is the question that I have. The trick, it turns out, is to just squish the Z position of the vertices in the vertex shader. This way, more vertices can fit inside the frustum. This does distort the mesh, but in orthographic projection, this actually doesn't make a visible difference, at least in my situation. Okay. So, does that mean I would want to squish it in the depth shader? This one? What does that do? Is this actually a good idea? It doesn't seem to affect... Oh no, never mind. I need to change the default settings of this, I guess. So let's see, we've got a scene of size 29, 12, 18. So I probably want to set the left and right. No, it's frozen again. That's weird. I don't know why it does that. Where is it? Yeah. So 29, well, 29 something 18. So we can say maybe 20 on width and height, because they're going to be, it's actually going to be 40, and then the far plane can be, what's the distance of the sun? It's 30. Far plane can be like, yeah, let's just leave it to 50 for now. What does that give us? Okay, most of it fits in the scene now, which is good. This is still very incorrect. This, however, is looking a little bit better, but still not quite accurate, because I believe we should be able to see the sun from the top of these things, right? Yeah. So if I'm at this pole, this flagpole, I can see the sun. Therefore, I should have a shadow. I mean, it should have a shadow, but it doesn't. Which means probably the projection is going to be slightly off. There we go. If I move it, I got one down there. Now I got one here. So what am I doing? I'm decreasing the far plane. And now I've decreased it too much, and I've cut off the top of the world or something. Great. The bottom of the world. So, yeah. Can't actually fit the whole scene in here. Which is kind of a problem. Unless I become the sun, and then I go up. Well, what if I go down? Well, I don't want to go down, I want to go up. And then, how do I become not the sun? There we go. And then we can modify the far plane again, make it further, but not too far, because otherwise it starts cutting off the values. Okay, that looks good, actually, I think. Okay, yeah. That's pretty good for this scene. The problem is I'm not going to be playing a game that's just this scene. So, I mean, I'm not going to be making a game that's just this scene. And I don't want to have to do crazy manual orthographic projection tuning all the time. That would be really annoying. So I think what I'm going to do is I'm going to figure out what this setting is. I think I have a hotkey to get the camera position. Don't I? So we got a 20 by 20, maybe do a 22 by, yeah, 22 by 22 looks good. I think there is a hotkey here for the camera position, or did I delete it? Damn it, I deleted it. So I don't know what the camera position is, or the sun position right now. I guess I could just check by adding a breakpoint. So let's have a look. I'll just add a breakpoint in the main loop somewhere, like here. Check the camera. No, not the camera. Sunlight position. Sun position. There we go. So it's okay. 8.4, 40, and then 5.6. So you're always using orthographic projection to get the parallel rays for the shadows? Yeah, that's the idea. As far as I understand it, you could probably do something crazy like make a really far away light and use perspective, but I have a feeling that you'd run into problems with that, with really large distances. I haven't tried it yet though. I might try it. So if we say the distance is actually going to be something more like 40 or 45, then we may get a better result here. So 8, yeah, why don't I just make this 8 and then this 5, and then this can be 45. That should be... That's going to be actually totally wrong. This should be more like 8 divided by 5, 5 divided by 8, 5 divided by 8. Well, it's not even that hard. Why can't I do it? 2.5 is half, and then 0.75. Something like that. Okay, I'll just do this. I think that'll give us a similar result. Oh. Okay, nope. That's really far away. Maybe something more like... this. Okay, yeah. Cool. Alright. I'm kind of happy with that result. And we are just about out of time. So I think I'm going to call it there. We didn't get the PCF working, but that's fine. I don't really care about that too much at the moment. What I care more about is probably not using this kind of shadow mapping, unless there's a way to make it automatically work for arbitrary scenes. Which I don't know. I know there's something called layered. I think there's layered shadow mapping, and you can have shadow maps that are generated like around the player as they move around, and then the ones further away have a really low level of detail, stuff like that. Maybe I'll look into that. Okay, I think it's called cascading shadow maps. So yeah, that was cool. I don't know what the right answer for this is. We just squished the Z values, which seems a bit weird to me. Like for example, this thing still doesn't have a shadow in the right spot. Actually, I guess it wouldn't. No, it would. It would have a shadow right there. Going down. Because from here. Yeah. Well, that's okay. Doesn't look exactly realistic, but I think it's okay for a first attempt. Or second attempt, really. Alright, I'm gonna go now. Got work to do. But thank you guys for tuning in. And I will see you on... Well, if you're around, I'll see you on Sunday. What day is it today? Friday. Yeah, Sunday. I'll be back on Sunday. So take care and have a good weekend.